Welcome to another deep dive. Today, I think you'll find especially intriguing. We're going to be exploring some pretty mind-bending concepts in quantum mechanics and cosmology, and really kind of delving into how these ideas challenge traditional scientific materialism.
Yeah.
Given your background and your openness to alternative cosmological models, I think you're really going to enjoy this journey.
Yeah, it's fascinating how quantum physics has a way of shaking up our assumptions about reality,
Right.
isn't it? It opens up so many possibilities that were previously inconceivable within a purely materialistic framework.
Absolutely. So to give you a little taste of what we're diving into today, we have a collection of articles, research papers, and some really intriguing notes that touch on things like scalar waves, quantum biology,
Sure.
and even some unexpected connections between physics and ancient wisdom traditions.
And what's really compelling is how these seemingly disparate fields start to connect when we view them through the lens of quantum mechanics. It's not about replacing scientific materialism, but about expanding it, recognizing that there might be more to the universe than we can currently measure or explain.
Okay, let's unpack this. One of our sources dives into this concept of scalar waves.
Okay.
Apparently, these are longitudinal waves, like sound waves, but in the electromagnetic field. Now, this is where it gets controversial, because some physicists believe they could travel faster than light.
Right. And it's important to acknowledge that the idea of scalar waves is considered fringe by mainstream physics. There's a lack of experimental evidence to support their existence, and they challenge some fundamental principles of our current understanding of electromagnetism.
So it's sort of like the ether theory that physicists used to believe in before Einstein's theory of relativity debunked it.
Exactly. The ether theory was a way to explain how light waves traveled through space, but ultimately, it was proven unnecessary. However, even though it was disproven, it highlights an important point. Scientific understanding evolves. We have to be open to questioning our assumptions, even those that seem foundational, as new evidence emerges.
So even if scalar waves turn out to be a dead end, the fact that they spark these kinds of discussions and push the boundaries of what we think is possible is valuable in itself.
Absolutely. The history of science is full of examples where what were once considered fringe ideas ultimately led to revolutionary breakthroughs. Quantum mechanics itself was initially met with skepticism and resistance, but it eventually transformed our understanding of the universe.
Okay, let's shift gears a bit and talk about quantum biology.
Okay.
Some of the sources we have explore how quantum mechanics might play a crucial role in living organisms, and not just at the molecular level,
Right.
but potentially at even higher levels of organization.
This is where things get really interesting. One source delves into how microtubules, those tiny structures inside cells, might actually function like quantum computers. The idea is that they could be processing information and influencing cellular behavior. Wow.
In ways we're only beginning to grasp.
Quantum computers inside our cells. That's a pretty radical concept. Are you saying we're all walking around with biological supercomputers?
It's definitely a speculative idea, but there's growing evidence that quantum effects might be more significant in biological systems than we previously thought. For example, research suggests that quantum coherence, that ability of quantum systems to be in multiple states at once, could be involved in processes like photosynthesis.
Photosynthesis. You mean the way plants convert sunlight into energy?
Yes. And it's not just photosynthesis. There's fascinating research on how birds might use quantum mechanics for navigation. It's thought that they might be using something called radical pairs in their eyes to detect the Earth's magnetic field.
Birds using quantum mechanics to navigate. That's incredible.
Yeah.
It seems like the more we learn about quantum mechanics, the more we realize its implications are far broader than we initially imagined.
That's exactly right.
It challenges us to expand our understanding of what's possible and to consider explanations that might have seemed outlandish just a few decades ago.
So if quantum mechanics is playing such a fundamental role in biological systems, does this point to some kind of deeper intelligence or organizing principle at work in the universe?
That's a profound question, and one that science is just beginning to grapple with. For centuries, science has largely focused on the material world, attempting to explain everything in terms of classical physics. But quantum mechanics throws a wrench in that machinery, suggesting that there might be more to the story than matter and energy alone.
Yeah.
Perhaps information, computation, even consciousness play a role in the unfolding of the universe.
Okay, my mind is officially blown. Quantum birds, cellular computers, the universe as a giant equation. It's a lot to process. I'm definitely hooked.
That's the beauty of these deep dives, isn't it? We get to explore the frontiers of human knowledge,
Hmm.
where things get messy, challenging, and incredibly exciting.
Where do we go from here? We've only just scratched the surface of these ideas.
Well, we have a lot more ground to cover. We'll explore how these quantum concepts connect to evolution, artificial intelligence, and even ancient wisdom traditions.
I can't wait. This is getting more and more fascinating by the minute. Get ready, folks. We're about to go even deeper down the rabbit hole.
So, picking up from our discussion about quantum effects in biology, it's fascinating to consider how these insights might influence our understanding of technology, especially computation.
Okay, how so? We talked about cells as potential quantum computers. But how does that translate to the technology we build?
Well, one of our sources brings up this intriguing idea of capability overhang in technology.
Okay.
It basically means that we often apply old ways of thinking to new technologies,
Right.
which limits their potential.
I see. So it's like trying to fit a square peg into a round hole.
Exactly.
We're trying to apply concepts from classical physics to a realm where quantum mechanics reigns supreme.
Exactly a great analogy. Think about our current computers. They're based on classical physics, using binary logic, zeros and ones. But quantum mechanics operates on entirely different principles, with superposition, entanglement, and the potential for vastly different computational approaches.
So you're saying we need to rethink our entire approach to computation if we want to truly harness the power of quantum mechanics, that we need to move beyond the limitations of our current binary systems.
That's one way to look at it. While building quantum computers is a significant step, perhaps we need to go even further and consider entirely new models of computation. What if we could design computers that operate more like biological systems, using the principles of quantum mechanics to process information in radically new ways?
That sounds incredibly complex. How would we even begin to design something like
It's definitely a huge challenge, but there's exciting research happening in the field of bio-inspired computing. Scientists are trying to create systems that mimic how biological organisms process information. They're exploring things like analog circuits, which might be better suited to handling the probabilistic nature of quantum mechanics.
log circuits, like the old school electronics with transistors and capacitors?
Yeah.
I thought those were a thing of the past.
It might seem counterintuitive, but these analog systems could be key to unlocking new possibilities in computation. They can deal with probability and uncertainty in ways that digital systems struggle with. And as we've been discussing, quantum mechanics is all about probability and uncertainty.
I see the connection. It's like we're coming full circle. We started with quantum effects in biology,
Yeah.
and now we're talking about how those same principles might revolutionize our technology.
What's fascinating is that when we start to think about these connections, we find echoes of ancient wisdom traditions that have long emphasized the interconnectedness of all things.
Speaking of ancient wisdom, one of our sources mentions this concept from Taoism called pu, which means uncarved block. Could you elaborate on that?
It's a beautiful metaphor for the primal state of existence, pure potential, unshaped by concepts or distinctions. It reminds us that even though we experience the world as separate objects and events, there's a deeper level of reality where everything is interconnected.
So how does this concept of pu relate to quantum mechanics?
Well, in quantum mechanics, we have this idea of the wave function, which describes all the possible states a quantum system can be in. It's only when we measure or observe the system that the wave function collapses and the system takes on a definite state.
So before measurement, the quantum system is like the uncarved block. Pure potentiality and the act of observation shapes that potentiality into a specific outcome.
Exactly. It's as though the observer participates in the creation of reality.
That's a powerful idea. It reminds me of the concept of consciousness playing a role in quantum mechanics, something we touched upon earlier.
Indeed, the idea that consciousness might be intertwined with the quantum world has been a source of debate and speculation for decades.
Didn't some physicists even propose that consciousness might be the very thing that causes the wave function to collapse?
Yes, that's one interpretation, although it remains highly controversial within the scientific community. The role of consciousness in quantum mechanics, if any, is still a profound mystery.
It seems like we're venturing into some pretty deep philosophical territory here. Are we saying that ancient wisdom traditions like Taoism somehow intuited these profound truths about the universe thousands of years ago?
It's certainly an intriguing possibility. Many wisdom traditions emphasize the interconnectedness of all things, the importance of consciousness, and the idea that reality is more fluid and dynamic than our everyday perceptions suggest. These ideas resonate deeply with some of the most mind-bending aspects of quantum mechanics.
It's almost like science is rediscovering ancient wisdom through a new lens, revealing the profound connections between what were once considered entirely separate domains of knowledge.
I think there's a lot of truth to that. Perhaps science and spirituality are simply different paths leading to the same fundamental understanding of the universe and our place within it.
So we've got ancient wisdom, quantum physics, cutting-edge technology, and the possibility that consciousness is somehow intertwined with it all. Where does this all lead? What's the bigger picture?
That's the ultimate question, isn't it? And I think we're just beginning to explore the vast implications of these ideas. One of our sources, for example, proposes that the principles of quantum mechanics and evolution might apply to the universe as a whole.
The universe itself evolving. What does that even mean?
It suggests that the universe might not be static, but rather a dynamic system constantly exploring new possibilities and selecting for stable, information-rich structures.
So the universe is like a giant evolutionary algorithm, constantly adapting and changing.
That's a fascinating way to think about it. And if that's the case, it means our current understanding of the universe is still in its infancy.
Wow.
We might be just one small step in a much grander cosmic evolution.
Wow, cosmic evolution, quantum consciousness, the uncarved block. It's just a lot to take in. It's mind-boggling, but also incredibly inspiring.
I agree. It's a reminder that the universe is full of mysteries. And the more we learn, the more we realize how much we don't know.
Right.
But that's what makes the journey of discovery so rewarding.
Okay. I'm ready for more. We still have a lot of fascinating material to cover.
Let's dive back in then. We'll explore how these quantum concepts connect to fields like artificial intelligence, the search for extraterrestrial life, and even the nature of time itself.
This is going to be one wild ride. Let's continue our deep dive. As we delve deeper into these quantum concepts and their implications, it's striking how they seem to bridge the gap between scientific inquiry and philosophical contemplation.
That's right. Quantum mechanics forces us to confront really profound questions about the nature of reality, the role of consciousness, and the interconnectedness of everything in the universe. These are questions that have occupied philosophers and mystics for centuries.
It's almost as if science is catching up with ancient wisdom, finding a new language to express truths that have been intuitively understood for millennia.
One of the sources we have touches on this connection between science and ancient wisdom in a rather unexpected way.
Okay.
It uses the example of a simple head of cabbage to illustrate some profound principles about the universe.
Wait, a cabbage? What does a cabbage have to do with quantum physics and cosmology?
It might seem like an odd juxtaposition, but bear with me. The source describes how the structure of a cabbage, the way the leaves fold and create those intricate pockets, is a beautiful example of hierarchical entrainment and pattern formation.
I see. So you're saying there's a deeper order, a pattern to the way a cabbage grows.
Exactly. And what's fascinating is that these same mathematical principles that govern the structure of a cabbage also appear in other natural structures, from seashells to galaxies.
So you're saying that the same principles that govern the growth of a cabbage might also be at work in the formation of galaxies. That's a pretty mind-blowing concept.
It might sound strange, but it's one of the most profound insights that emerge from studying complexity and self-organization. There seems to be a deep connection between the microcosm and the macrocosm, a kind of fractal geometry, where similar patterns repeat themselves at different scales.
Yeah.
And quantum mechanics might be the key to understanding how this intricate web of patterns arises.
This brings us back to the idea that there might be an underlying intelligence or organizing principle at work in the universe, something we touched upon earlier.
Absolutely. Many wisdom traditions have long emphasized the interconnectedness of all things, the idea that the universe is not a collection of separate parts, but rather a living, breathing whole. These ideas, which were once considered purely mystical or philosophical, are now finding surprising resonance with our scientific understanding of the universe.
It's as if science is providing a new way to appreciate and understand the wisdom embedded in these ancient traditions.
Yeah.
They're not so different after all.
Precisely. Both science and spirituality are ultimately quests for understanding, for uncovering the deep mysteries of existence. They might use different languages and methods, but they're both driven by the same fundamental human impulse to make sense of the world around us.
So where do we go from here? How do we integrate all of these ideas, from the mind-bending discoveries of quantum mechanics to the profound insights of ancient wisdom traditions into a coherent understanding of the universe and our place in it.
That's the challenge and the opportunity. It requires a willingness to expand our horizons, to step outside the confines of our current paradigms and embrace a more holistic, interconnected view of reality.
It sounds like you're calling for a new kind of science, one that's more open to dialogue with other disciplines,
Yeah,
one that's willing to explore the frontiers of consciousness and the nature of reality itself.
I think that's essential. We need a science that's both rigorous and imaginative, a science that embraces both the analytical power of reductionism and the integrative perspective of systems thinking.
It seems that this shift in scientific perspective would require a corresponding shift in our cultural values. We need to move away from a purely materialistic worldview and embrace a more holistic understanding of the universe, recognizing the interconnectedness of all things.
I agree. We need to cultivate a sense of wonder, a deep appreciation for the intricate web of life, and a willingness to embrace the mystery and uncertainty that lie at the heart of existence.
This has been an incredible journey. We've covered so much ground, from the bizarre world of quantum mechanics to the philosophical implications of cabbage structure and everything in between.
And through it all, we've seen how these ideas challenge our assumptions about reality and open up new possibilities for understanding the universe and our place within it.
I'm left with a sense of awe and excitement. The universe is far more mysterious and wondrous than we often realize, and the journey of discovery is just beginning.
That's a perfect note to end on. Thanks for joining us on this deep dive. Keep exploring, keep questioning, and never lose that sense of wonder.
And until next time, keep looking for those hidden patterns, those unexpected connections that reveal the underlying unity and beauty of the cosmos. You never know what incredible insights might be waiting to be discovered.